Hello and welcome to the Honors Chemistry Stoichiometry Review. This is in your workbook. Walk through a couple different concepts here that you may be interested in prior to our test. Alright, so first of all, we got determine the following number of molecules. So in this case, we have moles. And from there I can go to number of molecules, and that's erasing there, so I'm going to get rid of that. We got moles, and from there we'll go to molecules. This is using Avogadro's relationship, 6.022 e to 23rd equals 1 mole. And you could also, for moles, go to grams. Okay, and this is going to be using the molar mass. Usually do all of our stoichiometry in moles. We could do it in molecules, but works just as well, but usually do it in moles. So if we're in moles, we usually don't have a reason to go to molecules, but the question asked, go to molecules. So 9.8 moles, okay, using vector label, get rid of moles. Go to molecules. Both of these problems will be done exactly the same way. You just take the 9.8, substitute the 5 in. So I'm not going to show both of them. 1 mole equals 6.022 e to the 23rd. And I'll plug that to my calculator. 9.8 times 6.022 e to the 23rd. And I get a whopping 5.90 e to the 24th. Alright, in this case, the following determine the number of moles. So we're going to go from molecules here back to moles. So we're just going to reverse this process. 2.3 e to the 12th. Dot line, get rid of molecules. And go to moles. 1 mole is 6.022 e 23rd. And just reverse that process. 2.3 exponential to the 12th divided by 6.022 e to the 23rd, and I get a whopping very small number of moles, but it is going to be, and remember this is 23, 3.81 e to the negative 12th moles. Alright, and again, this one is exactly the same. Just plug a new number in here and divide by Avogadro's number. Determine the formula weight, or another way of saying that would be the molar mass. Another way of saying is molecular weight. So this is going to be 1 times 1.00 times 2 equals 2 grams per mole. That's how much 1 mole weighs. For sodium sulfate, I'll do that one over here. This guy is 23 times 2 is 46. The sulfur is approximately 32, and then the oxygen is going to be 16 times 4 for a whopping 64. Add up the 46 plus 32 plus 64 is the mass of 1 mole, which is 142 grams per mole. NaOH, sodium is 23 plus the 16 for the oxygen plus the 1, 6, 7, 8, 9, 10, carry the 1 is 40 grams per mole. Determine the following mass in grams. So we're just going to flip my moles to my grams. Now 3.3 moles, get rid of moles and go to grams. This is my molar mass. 1 mole weighs 32 grams, and therefore 3.3 times 32 equals right around 105 grams. Alright, next problem, I got 45.2 grams per or moles of iron 3 oxide. So again, 45.2 moles, get rid of the moles and go to grams. Same process. Need to add the molar mass up for iron oxide. Iron oxide, 16 times 3 is 48, and then the iron is 55.8 times 2. Pretty simple math. 111.6. Again, I'll just write that down. 111.6 plus the 48 equals 159. That's how much 1 mole weighs. So if we have 45 of those, is a pretty large number, 7,213 grams. Determine for the following, determine the amount of moles found in each mass. So now we're going to do just the reverse process. 22 grams per mole, so grams, 22 grams, get rid of the grams and go to the moles. 1 mole for oxygen is 32 grams, so we have less than 1 mole. 22 divided by 32 is 0.687 moles. This guy has a molar mass of 180, so again, I added everything up for 180, so then we got 305.6 grams. Get rid of grams and go to moles. 1 mole is 180 grams. 305 divided by 180 equals 1.69 moles. Alright, now we're moving on here. We got the following. For the following, determine the amount of moles for the following equation. Okay, so just in moles, there's all my stoichiometry can be done in moles. You can use this up in a little ice table. 6 moles of oxygen, how much? NO2. So I'm giving just initial amounts, alright, of 6 moles of oxygen. It's not giving me amount of nitrogen, so I'm assuming that it's in excess. And I just want to jump from here to this guy. And a 2-to ratio is going to be 6 moles. 6 at a 2-to-2 ratio is just 6 moles of NO2. That is my answer. Next one, if one formed 4.22 moles of nitrogen monoxide, how much nitrogen would be required? So I'm going to go from here to here in moles, and it's a 2-to-1 ratio. So 4.2 moles of NO2, 2-to-1 ratio to the N2, NO2, and it is going to be 2.1 moles. So there we go. Alright, number 15 says we have 92.2 grams of aluminum, right here, is added to excess hydrogen peroxide. How much aluminum oxide would be formed? Alright, so I have this given to me in grams, and I want to know the aluminum oxide formed, and it doesn't say which one. I'm going to just go to moles and then to grams. So convert to moles, 90.2 grams, get rid of grams and go to moles. It's already balanced for me, but 1 mole for aluminum is 27 grams. Then for every 4 aluminums, I get 2 aluminum oxides. And then from there I can stop if I want to stop in moles. The moles at that point would be 90.2 divided by 27 times 2 divided by 4 gives me a whopping 1.67 moles. And then if I want to go get out of the moles and back to grams, which questions quite often ask, I would need to add up the molar mass of Al2O3. This is going to be 27 times 2 is 54, and this is 48. 102, and times your 1.67 equals 170 grams. There we go. Last problem here, it says I have how much of the chromium oxide here was produced in grams when 18 grams of sodium hydroxide and 8.2 grams of the chromate is is used. So break my problem out, convert both of those grams into moles, and there we'll run our ice table through. Alright, so we're going to convert these two guys from grams to moles. And let me grab my pen here. First thing as we do that, we need to get our molar mass. I'll give myself a little more room here. I have the Alright, so getting back to this, we got first of all, molar mass. I have 6 NaOHs. Add all these pieces up, it's 40 grams per mole, plus the Cr2SO4 3, and this guy here has a lofty molar mass. 2 chromiums. Chromium is 52 each. We got sulfur, which is going to be 32. And you got 3 of those. Plus we got another oxygen, which is 16. And there's going to be 3, 4, 12 of those. 392 grams per mole, yielding 3 Na2SO4s. If need be, at some point, I will get the molar mass of that, and then the 2 CrOHs, and there we go. And I'll get more mass of that if I need be. It says how much chromium hydroxide was produced in grams when. So they want to find out this. When 18 grams of NaOH, 18 grams of this is added to 38.2 grams of this. Very first thing I want to do is get these things in moles. I have 18 grams, get rid of the grams, go to moles. 1 mole is 40 grams. So I have less than 1 mole. 18 divided by 40 is 0.45 moles. Here I have 38.2 grams. Grams to moles. 1 mole weighs 392 grams. 38.2 divided by 392 equals 0.097. 0.097. At this point, I have less of this. This is being used up at a greater rate. And I'm going to say, even though we have more of this, I'm going to say looks like 6 times might run out faster. Let's try it. 0.45 down to 0, 1 to 6 ratio, show that math here. 0.45 moles at a 6 to 1 ratio. This is the going to Cr2SO4, or the reactant, and that equals 0.075 moles are needed, minus 0.075 moles, and doing that subtraction means I have a positive 0.022 moles left over. Okay, so this is verified as being my limiting reactant. Jump from here to here, and at a 0.45 moles at a 6 to 2 ratio will give me my moles of the product I'm looking for. 0.45 times 2 divided by 6 equals 0.15. So 0.15 moles, and that would be my answer if it's in moles, but they want my answer to be in grams. So I'll need to add up my molar mass of these guys. So the hydroxide is 17. This guy is 16, this one is 17. 17 times 3 equals 51. So this guy is 51. The chromium is 52, if I'm rounding. 52, so that grand total of 103 grams per mole. Get this out of moles and into grams. 1 mole is 103. Right? 103 times 0.15 equals 15.45 grams, and that is my answer. Pretty much everything in there that you need. We got a little bit of an ice table and mass to mole calculations. Thank you.